So techniques to determine machine cell formation. A couple of different techniques to be able to figure out how to set up your formation. You can have a row and column masking algorithm. You can have a single linkage clustering, and you can have an average linkage clustering. Now, I'd like to explain these during the example problems that we have as we go through them. I think that's the best way to do it. So I'll keep that to then, and then we'll move forward. Right now, for this portion of the slides, these are more qualitative portions to go through types of qualitative questions that you will be asked. And there will be quite a bit of qualitative questions. Be prepared during the exam. At least that's what I felt a couple of years ago. They'll come up with a question out of nowhere. Just a solid strike of something you've never heard before. But at the same time, they have a good method of analyzing if nobody got the question. Should they keep it on, or should they remove it? Should they calculate it part of the grade, and so on and so forth? So just be prepared, but don't be intimidated. Well, I like to put it, if you took the School of PE course and you didn't know the answer, then probably a lot of people didn't know it either. So just move on with it. All right, now let's talk about factors that affect flow pattern. It is the number of parts in each product, the number of operations in each part, the sequence of operation in each part, number of sub-assemblies, number of units, the layout, desired flexibility, location of the service area, and the type of building. All right, let's start from the bottom, going all the way up top. How the factor that affects the flow pattern, type of building. What would the type of building be? For example, the vertical flow that we were discussing earlier during the slides, that was due, in the example that I was giving, that was due to, it was actually in Edmonton, Canada, and the facility was in a landlock, and they had to go vertical, so they set up the facility vertical in a two-story building. As they set it up, the type of building affected the flow pattern. They had to go vertical. They had no other choice. Locations of the service area and the desired flexibility, actually, I think those go hand in hand. For example, if you have a facility that is casting iron or casting drill bits or something around those lines, then you're going to need a cooling system. The cooling system is going to require water. The water and the drainage may be on one side of the facility. So the one side of the facility limits the service area and limits your desired flexibility. So that affects your flow pattern. Is it a product versus a process type? So are we running a facility where it's by process? These are the lathe equipment, and this is all we're going to do, the turning of the metal. Or are we doing it by a product where this is where we make calculators? And this is where calculators on this side will be mobile phones on the other side. Those are issues that limit the flow of the pattern. And then, of course, you have the number of units to be produced. And this is where we talked, if you have a large amount with a small sequence of operations, small number of operations, and this would be for both the number of units and the sequence of operation, you may go with a straight line layout, and that would affect your flow pattern. You have the number of sub-assemblies. So if you're building a large product, so this is the size of the product, that requires, like a plane, like a Boeing plane, and you have all these fastening tools, all the screws, everything that goes into the building of the plane, then that would dictate how your flow pattern would be. And then of course, the number of assemblies may also dictate the number of operations. Or if it's just a machining operation, not a sub-assembly, then you'll have milling, grinding, turning, and we'll go through those. We'll go through those towards the end of the class. We have a section about machining that's also covered in this class, and we'll go through those in depth.